In ICND1, I demonstrated how we could use a routing protocol to be able to exchange information impacting IPv6. I want to do the exact same thing here, but I'm going to do it for EIGRP. In fact, what we'll do is we'll even repeat the illustration that we saw in ICND1 for IPv6 operating on OSPF version 3. So what we want to do is let's go back to our equipment and do some basic configurations that are going to be necessary for us to be able to support IPv6. First of all, on these devices, what I'm going to do is I'm going to clear my screen. And again, recognizing the fact that I have that 4 router topology, 1, 2, 3, and 4, connected via 0, 0s on this end and 0, 1s on my verticals. What I want to do is I want to start using IPv6 addresses. So what we're going to do is we're just going to emulate our address range. We said that we had 10 dot, here it was .12. So it's 10.1.12.0. Here it was 24.0. Here it was 13.0. Here it was going to be 34.0. So 10.1.34.0. Now these are the networks that we have. So what I want to do is I'm just going to come up with IP addressing that I can actually use to demonstrate how this is going to work. So first of all, we need to enable IPv6 routing on all of our devices. I'll just simply go through and do that on each one. Config T, IPv6 unicast routing enabled. Exit. IPv6 unicast routing enabled. IPv6 unicast dash routing enabled. R4, config T, IPv6 unicast dash routing. So I've turned unicast, IPv6 unicast routing on each of these devices. So now let's go back through and assign our addresses. I'm going to use the 2001s, and I'm going to also go in so far as to do the basic configurations here. So what I'm going to do is I'm going to say interface FAOO, which is going over to R2. What I'm going to say here is it's going to be interface EOO. It's going to be IPv6 address 2001 10:1:12:1/64. That gave it an IP address. Do the exact same thing for E01. IPv6 address 2001 10:1:13:1/64. So I've just given it IP addresses. Let's cut over to R2 and do the same thing. Config T, interface E00 IPv6 address 2001:10:1:12:2/64. Interface E01 IPv6 address 2001 10:1:12:24:2/64. All right, now let's go down and do the others. On R3, interface E01 IPv6 address 10:2001. Keep fat fingering it, sorry. 10:1:13:3:3/64. Let's do the other link across the way where we're going to say interface E00 IPv6 address 2001:10:1:34:3/64. And then the last configuration is going to be on R4 itself. So interface E00 will be IPv6 address 10:2001:10:1:34:4/64. And E01 is going to be that vertical connection up to R2. It's going to be IPv6 address 2001:10:1:24:4/64. So all we've done is created these interfaces. Now let's see if I can actually ping. So I wanted to be able to do ping to 2001:10:1:24:2. And I have reachability. So it seems to be working. Now what I want to do is I want to go so far as to configure my system to run EIGRP for IPv6, what's best known as EIGRP version 6. So I'm going to take myself out of the equation so my body's not in the way, and we're going to go ahead and enable this process. We're going to do it on all 4 of these devices, R1, R2, and R3. To make this work, I'm going to simply say IPv6 router EIGRP, and I'm going to look here and notice that I can use an autonomous system number. Now, what I'm going to find here is now I want to be able to advertise these individual interfaces. So I'm going to go to interface E00, and I'm going to say IPv6 EIGRP1. I'm going to go interface E01, do the same thing. IPv6 EIGRP1. So all I did here is I just created an autonomous system of 1. So we're going to cut over to R2 and see if we can't do the marrying config. So IPv6 router EIGRP1 interface E00 IPv6 address, no, I already have the addresses, excuse me, IPv6 EIGRP1 interface E01 IPv6 EIGRP1. Now notice I bring my link up. I formed a neighbor relationship, and the neighbor relationship that I formed is with a link local prefix, FE80. So it's not using my routable address, it's using my link local. So let's go ahead and do the rest of the configuration on each of these devices. So again, router EIGRP, keep wanting to use IPv4. IPv6, router EIGRP, what am I doing here? Oh, under the interface. IPv6 router EIGRP1. All right, now what I'm going to do is going to go interface 00 IPv6 EIGRP1 interface E01 IPv6 EIGRP1. And then what we'll do now is we'll move into this and start taking a look at what's happening on R4, where here I'll say router EIGRP1. I'm sorry, that's not what I wanted to do. I want to say IPv6 router EIGRP1 interface FO or EOO IPv6 EIGRP1 interface E01 IPv6 EIGRP1 under the interface E01 IPv6 EIGRP1. Now the problem here is that I have all these neighbors. Show IPv6 EIGRP neighbors is the command that I'm going to see, and still notice I'm using these link local addresses. Now the problem is that I don't necessarily know where these addresses, how they were actually created. So I could have specified my link local addresses in order to be able to make this manageable. Typically I use FE80 : and the router number 1, 2, 3, 4, 10, 12, whatever, how many routers I have in my labs. Now, also part of this, we need to understand that we have an IPv6 routing table now. So what we're going to do is I'm going to come up here and say show IPv6 EIGRP, or show IPv6 route for EIGRP. And now we're going to see the prefixes that we're learning in our infrastructure. Now the problem here is I'm on R4, but I don't really have anything other than just connected segments device to device. So what I'm going to do is I'm going to go to R1 and I'm going to add an address. I'm going to say interface LO0. I'm going to say IPv6 address 2001, and I'm going to say :1:1:1/128. And what I'm going to do also is say IPv6 EIGRP1, and I'm going to advertise that. Now what I'm going to do is I'm going to go back over to R4 and repeat my command, and now what we're going to see again is the capacity to do load sharing across this link to reach that destination of 2001 :1:1:1. So again, this gives me the capability of being able to fire up my system, and I also need to recognize the fact that all of my other commands are going to be available to me. I just need to use the IPv6. If I want to look at my neighbors, show IPv6, EIGRP neighbors. If I want to look at my topology table, show IPv6, EIGRP topology table. There's all of the information. Notice I have my two successor prefixes here. Also notice in the confines here, I can say show IPv6 EIGRP interfaces, and it's going to give me the list of interfaces that are actually participating in the protocol. I can even go show IP route, IPv6 route, EIGRP, and look just at my EIGRP prefixes. So we see here the fact that we have a lot of information that's actually being exchanged and bringing this system up. And the best way to really explore this is to go ahead and build the configurations on your own and verify that you have reachability. So for instance, on R4, can I ping, let me go ahead and select my device, can I ping 2001:1:1:1:1? And yes, I can. Can I do a trace route? So let's do a trace route to 2001:1:1:1:1, and what we're going to see here is we're going to be doing the load balancing exactly as we discussed and implemented. So when it comes to configuring the whole system, EIGRP, it's just not that big of a deal to do. All we have to understand is know our IPv4 processes for EIGRP inside and out, and it's just going to be an issue of adding IPv6 to the command syntax to do our troubleshooting and our verification commands. But also bear in mind, like I said, as we move into IPv6, we're going to have some configuration under the routing process. We're going to have other configuration taking place under the interface. So with that being said, that rounds out EIGRP. I'll see you guys in the next lesson.